Hi guys, Tiny Maths back with another video. Today we'll be learning how to divide fractions. This lesson has two stages to it. In the first stage, I'll be describing the method for dividing fractions. In the second stage, we'll work on a few examples to see how the process is used. As a side note, you'll need to know how to multiply fractions, otherwise you'll get stuck in the middle of this process. I've linked to my tutorial on how to multiply fractions in the description in case you need to refresh your memory on the subject. To understand this process, we first need to look at how a division problem with fractions is constructed. Take the problem 2 over 3 divided by 1 over 2. This problem is made up of three elements: a number on the left, which is a fraction, an operation in the middle, which is division, and another number on the right, also a fraction. In this problem, you are trying to find out how many times the number on the left, 2 over 3, can be divided by the number on the right, 1 over 2. Stated differently, we're trying to find out how many times 1 over 2 goes into 2 over 3. Now you might initially be confused about how to deal with this problem, but there is a simple trick to this, which involves changing two of these three elements, the last two. Once you've made the changes, the problem will be easier to handle. Here's what to do. The first step is to keep the fraction you are trying to divide as it is. We are trying to divide 2 over 3, so keep 2 over 3 as it is, don't change it. For the second step, take the other fraction, the one we're trying to divide 2 over 3 by, that's 1 over 2, and invert it. What that means is that you flip the numerator and denominator so they swap positions. The numerator goes to the bottom and the denominator goes to the top, giving you a new fraction 2 over 1. This is the inverse of 1 over 2. It's also called the reciprocal of 1 over 2. Note that 2 over 1 is actually just 2. All whole numbers are actually also fractions. The denominator is 1. We just normally don't need to write it. We'll keep 2 as 2 over 1. In the third and final step, you change the operation from division to multiplication. So our problem, which was 2 over 3 divided by 1 over 2, has now been converted to 2 over 3 times 2 over 1, and this is a multiplication problem. We wanted to divide by a specific number, 1 over 2, but instead we are now multiplying by its reciprocal, 2 over 1. Both of these have exactly the same effect, and I will show you that this is true later on. Now the problem is converted, we'll use the straightforward method of multiplying numerators together and then denominators together, and simplify the result or convert from an improper fraction if either of these steps are needed. So, with 2 over 3 times 2 over 1, multiplying numerators we get 2 times 2 equals 4, and multiplying denominators we get 3 times 1. So the new fraction is 4 over 3. It's an improper fraction. We can view this as a division problem by asking how many times 3 goes into 4? It goes once with a remainder of 1. So 4 over 3 can be rewritten as 1 and 1 over 3. So our answer is 2 over 3 divided by 1 over 2 equals 1 and 1/3. You can actually see that this is the right answer by using a visual representation of this problem. This is what 2 over 3 looks like, and this is what 1 over 2 looks like. Let's call it half. By 2 over 3 divided by half, we mean how many of these halves, the size of this area, can fit into 2 over 3, the size of this area. We want to fill in the entire 2 over 3 area using the whole of or parts of the half. Well, you can immediately see that 2 over 3 is bigger than 1 over 2, so 1 over 2 goes into 2 over 3 at least once. Now 1 over 2 doesn't go into 2 over 3 two times because 2 halves would be too big. So you can only add a small part of a half to the full 1/2 you already used in order for the entire area of 2 over 3 to be filled in. Well, what was our answer? It was 1 1/3. That's how many halves go into 2 over 3. That's 1 entire half and 1/3 of a half. Let's divide our half into 3 different sections. Now let's take 1/3 of a half, one of these 3 pieces, and add it to the half we already used to fill in some of the 2 over 3 area. Look, once we add it, the whole of the 2 over 3 area is filled in. And to do that, we used a full half and 1/3 of a half. In other words, the amount of halves that go into 2/3 is 1 1/3. So 2 over 3 divided by 1 over 2 is 1 1/3. So our method of inverting the fraction we are dividing by and changing the division sign to multiplication really does work. Of course, you can always use a calculator to compare the two versions, 2 over 3 divided by 1 over 2 versus 2 over 3 times 2 over 1 to see that both give you the same answer. Let's use this method to solve 2 more problems. Each problem has a slight variation in format. In the first variation, 6 divided by 9 over 4, we're dividing a whole number by a fraction. And in the second variation, 6 over 7 divided by 2, we're dividing a fraction by a whole number. We'll start with 6 divided by 9 over 4. Well, it looks like we have an issue here because 6 isn't a fraction. But that doesn't matter because in the first step of the process, whatever number you are trying to divide, you don't alter it. So since we're dividing 6, we keep it as it is. Then we have to invert the fraction we're dividing by. So we flip 9 over 4 and it becomes 4 over 9. And finally, we change the division sign to multiplication. So 6 divided by 9 over 4 is the same as 6 times 4 over 9. We can also change the format of the whole number and make it look like a fraction by giving it the denominator 1. The value doesn't change, it still equals 6. Now we multiply horizontally, giving 6 times 4 over 1 times 9, which equals 24 over 9. This is an improper fraction, so we can deal with it as a division problem. 9 goes into 24 twice, 9 times 2 equals 18, and that leaves a remainder of 6. So we can rewrite 24 over 9 as 2 and 6 over 9. The fraction part can be simplified by dividing by the highest common factor of 6 and 9, which is 3. So dividing top and bottom by 3 makes the fraction 2 over 3. Now adding that to the whole number, we get the mixed number 2 and 2 over 3. Therefore 6 divided by 9 over 4 equals 2 and 2 over 3. Now let's solve 6 over 7 divided by 2. So first, since we are dividing 6 over 7, we keep it as it is. Now for the number that does the dividing, we have 2, which is not a fraction. Is that a problem? No, just simply rewrite it as a fraction by putting the denominator 1 on the bottom. And again, the value does not change, it still equals 2. So now the number that does the dividing is the fraction 2 over 1. We now have to invert it, and that gives the fraction 1 over 2, which is the inverse of 2 over 1. Then change the operation to multiplication, and we get the altered version of the problem, 6 over 7 times 1 over 2. Multiplying horizontally gives 6 times 1 over 7 times 2, which equals 6 over 14. We can reduce this because 6 and 14 have a highest common factor, which is 2. So dividing both top and bottom by 2, we get 3 over 7. Therefore, 6 over 7 divided by 2 equals 3 over 7. And there you have it. That's how we divide fractions, using the simple method. Remember, keep the number to be divided, change the operation to multiplication, and finally invert the number that you're dividing by. So you are no longer dividing by the number, but multiplying by its reciprocal, and that has exactly the same effect. Why don't you take some numbers and make your own examples? You'll find the process pretty easy after some practice. Well, that's it for now, guys. Don't forget to check out my video on how to multiply fractions if you need a refresher. I'll link to it here. Well, thanks for watching. Until the next video, take care.